Let's go ahead and practice adding and subtracting polynomials together. For number one, we are adding these two linear binomials together, and keep in mind when we are adding polynomials together, we actually can drop the parentheses right away from the beginning. So if it helps you clear things up, go ahead and just get rid of them. The reason being is because there is technically an invisible 1 that's right in front of these parentheses, and if you just go ahead and distribute this 1 to both of these terms, nothing changes, okay? This 2x and 4x can combine to make 6x. And then a little bit after that, what we're going to do is take a look at this 9 and this 5, and combining those, we're going to be adding on 14, okay, just like this. This right here would be our most simplified expression. For number two, notice that we are adding again, so we can go ahead right from the beginning and just drop the parentheses. So we have 3y plus 2 plus 7y plus 3. And then we're going to look for some like terms here, right? So 3y and 7y are like terms. They're going to combine to make 10y. And then we can go ahead and combine these constant terms of 2 and 3. And if we combine a positive 2 and a positive 3, that's going to make a positive 5. So this is going to be as simplified as we can make this expression. Let's go ahead and check out number 3. So for number 3, it looks like we are adding again. And so if we are adding, we can go ahead and just get rid of the parentheses. So we have 9a minus 5 plus, and I'm going to put this negative 7a in parentheses just to keep it organized, and then plus this 9. All right. And then what we're going to do next is we are going to look for some like terms. So 9a plus the negative 7a, it's going to combine to make a total of positive 2a. I'm going to go ahead and write that just like this. And then afterwards, we're going to combine some like terms. We have this negative 5 for constant and a positive 9. If we combine those two, we're going to get positive 4. So this right here would be the most simplified expression. For number 4, it looks like we are adding again. So let's go ahead and drop the parentheses. So we have negative 7m plus 10 plus this negative 6m. And again, I'm just putting this parentheses around the negative 6m to keep it organized because we have two operations next to each other, two symbols. So this negative 7m plus this negative 6m is going to make negative 13m. And then after that, let's see what we're going to combine. Looks like we have a constant of positive 10 and negative 2, and that will combine to make a positive 8. So this would be our expression of negative 13m plus 8. On to number 5. For number 5, we have our first expression that has subtraction in it. So keep in mind, just like in number 1, the way I drew that, there is an invisible 1 here. So we actually have to distribute a negative 1 to both of these terms inside here. So subtraction is the only one you have to actually worry a little bit more about. Addition is not too bad because you can just drop the parentheses. But for these ones, when you go ahead and write them without parentheses, keep the 4p plus 9, or just keep the first terms the same. But you're going to flip everything in the second one. So negative 1 times p is going to be negative 1p, and negative 1 times positive 5 is going to be a negative 5. So just go ahead and make sure that you flip everything in the second parentheses when you are subtracting. Okay, this is 4p, take away 1p, so 4p minus 1p is going to be 3p. And let's see what we have after that. It looks like we have a positive 9 and a negative 5. So 9 minus 5 is going to be 4. So we're going to add a positive 4 on the end here. So our final expression here is going to be 3p plus 4. For number 6, we have subtraction again. So keep in mind there is technically a negative 1 in front of these parentheses, and we are going to distribute it. So what that ends up doing is just flipping everything in the second parentheses. So again, keep this 8n plus 5 the same. Never touch that if there's no symbol in front of it. Then it's going to be a minus 3n, and then it's going to be a minus 4. So those both get that negative in front. Okay, we can go ahead and combine this 8n and minus 3n. So 8n minus 3n is going to be positive 5n. And then let's see, we have this positive 5 take away 4. That's going to be a positive 1. So we're going to go ahead and add a 1 at the end here for our constant. So 5n plus 1 will be our most simplified expression. Moving on to number 7. For number 7, looks like we have another expression where we are subtracting. So let's go ahead and take that minus sign and distribute it. So how are we going to write this? I'm going to write 5x plus 13. Hopefully you noticed I'm being consistent there. I'm not touching that. And then it's going to be plus 2x, right? Because we're going to flip it, and then it's going to be minus 5. All right, just don't forget to do that. For our like terms, we have 5x plus 2x. That's going to make a total of 7x. And then for our constant terms, we have 13 minus 5. That's going to be positive 8. So I'm going to write a positive 8 at the end for our constant. So we have 7x plus 8 as our final answer. For number 8, we are subtracting once again. So we have negative 8y minus 3 stays the same. And then we're going to write plus 5y because that minus sign is going to flip it. And then we have minus 7 because it's going to flip that as well. Combining like terms, we have negative 8y plus 5y. And if we do that, we're going to still have a negative. So we're going to have a negative 3y. And then after that, we have a negative 3 for a constant and a negative 7. A negative 3 and a negative 7 are going to combine to make a negative 10. So I'm going to write plus negative 10. But keep in mind that we can also simplify this a little bit more. Instead of writing plus a negative, we can also write that we are subtracting a positive. So we can write negative 3y minus 10. So again, same thing, but we try to write our answer with less symbols when possible. Let's check out number 9. So for numbers 1 through 8, we had all linear binomials. And for this one in number 9, you're going to notice that we have an exponent of 2 as their highest exponent. So these are quadratics. And because there's 3 terms in each polynomial, these are trinomials instead here, right? Because we here have an addition between these two polynomials, we can just drop the parentheses, right? We're distributing a positive 1. So we have 2x squared plus 4x plus 7 plus 5x squared plus x plus 2. And again, I'm writing this out, and obviously you can do it just from looking at the original problem if you'd like to, but I'm just trying to be super clear here. If we combine this 2x squared and 5x squared, those are like terms, that's going to be positive 7x squared. Okay. Moving on to our normal x terms here. So we have a positive 4x and a positive 1x. Don't forget that 1 in front of this one. So 4 plus 1 is 5. So we're going to have a positive 5x afterwards. And then if we look over at our constant terms, we have a positive 7 and a positive 2. That's going to combine to make a positive 9. So we'll go ahead and write plus 9 at the end. This would be our most simplified answer. For number 10, we have addition again. So right from the start, we're going to ignore the parentheses. So I'm going to go ahead and write this out, but feel free to skip this part if you would like to. So I'm just going to go ahead and rewrite this as plus negative 2y squared. And then I'm going to write plus 6y and then minus 5. So just ignore the parentheses because we're distributing a positive 1. So starting with our highest degree or highest exponent, we have these 5y squareds and minus 2y squared. So 5 take away 2 is going to be 3. So we have 3y squared. And then moving on to our regular y terms, we have negative 4y and positive 6y. Combining those, that should be a positive 2y, right? So plus 2y. And then moving on to our constants terms, so we have this plus 7 and minus 5. Positive 7 take away 5 is going to be a positive 2, so we'll write plus 2. So this would be as simplified as we can make this. On to number 11. For number 11, we have another set of trinomials, but now we are subtracting, so be careful with the second grouping. For the first grouping, this 6x squared is going to stay the same. This plus 9x will stay the same, plus 8 the same. But then we're going to flip everything over here, so it's minus 2x squared, and then minus 5x, and then minus 3. Again, if you can do that without writing it, feel free to do so, but I get a little confused sometimes, so I like writing it out. 6x squared minus 2x squared are going to combine to make 4x squared. Okay, moving on to the next set of terms, we have a positive 9x take away 5x, so that's going to be a positive 4x. And then finally, onto the constant terms is positive 8 take away 3. That's going to be a positive 5, so I'm going to go ahead and write plus 5 at the end. This will be our most simplified expression. For number 12, we have another subtraction problem, so we're going to leave this negative 3k squared alone, leave this plus 9k and plus 8 alone, and then we are going to subtract 2k squared. Then taking away a negative 5k is really adding a 5k, and taking away negative 7 is really adding a 7. So we're going to make sure we flip all of those. Combining this negative 3k squared and this negative 2k squared, that's going to be negative 5k squared. Then moving on to our regular k terms, we have positive 9k and positive 5k. That's going to make a positive 14k when we combine those, plus 14k. And then finally, we have a positive 8 and a positive 7, and that's going to combine to make a positive 15. There's our answer. Let's see number 13. For number 13, we are adding, so let's go ahead and just ignore the parentheses. So we have negative 4m squared minus 5m plus 9. So that's going to stay the same, but then in the second set of parentheses, these will stay the same as well. So we're going to have this negative 5m squared, and then we're going to have this minus 9m, and then this minus 8. All right, so nothing's going to change because we are adding. Starting off with the m terms, or m squared terms rather, we have negative 4m squared, negative 5m squared. Combining those, we're going to get negative 9m to the second power. Then moving over to the regular m terms, we have negative 5m and negative 9m. Combining those, we're going to get a negative 14m. So I'm going to write plus, and I'm going to write a negative 14m. If you want to go right to writing minus, that's also okay. And then finally, we have a positive 9 and a negative 8 for our constant terms. They're going to combine to make a positive 1. So I'm just going to write plus 1 at the end here. Writing this a little bit more simplified because we have that plus minus or plus a negative. I'm going to write negative 9m squared, and then I'm just going to write minus this 14m. Again, that's the same thing. And then we're going to write plus 1. This will be our final expression. For number 14, be careful of the minus sign. So the first set of parentheses are going to stay the same. So 5n squared minus n plus 4 all stays the same, but it's going to be minus 8n squared. We're taking that away. If you take away a negative 7n, that's really just plus 7n. And if you're taking away 3, we should take away 3. So keep in mind we're subtracting everything over there. Then moving on to the n squared terms, we have 5n squared, take away 8n squared. That's going to be negative 3n to the second power. Then moving over to our n terms, we have negative 1n plus 7n. So negative 1 plus 7 is going to be positive 6. So we're going to have positive 6n. And then finally, we have a positive 4 take away 3. 4 take away 3 is going to be 1. So we're going to write plus 1. This right here will be our most simplified expression. Number 15. For number 15, we have this thing called a cubic polynomial. So we had 2 terms earlier, we had 3 terms, and now we have 4 terms. So these are cubic polynomials because the highest power is to the third power. Okay, so we are adding here, so all the rules are going to stay the same. So if we're adding, we can drop the parentheses. I'm going to write 4x to the third power plus 5x to the second power. Take away an x, add 7. Plus 9x cubed minus 4x squared minus 5x, then plus 4. Alrighty, so we have everything in one long sentence. I just dropped the parentheses because we did not need them. Now I'm going to go ahead and combine the highest exponent first, or highest degree, and that's going to be this 4x cubed plus 9x cubed, and it's going to be 13x cubed. Following that, we're going to move on to the x squared term. So we have positive 5x squared, take away 4x squared. So 5 take away 4 is going to be 1. So we're just going to be left with x squared. Then moving on to our just normal x terms, we have negative 1x and negative 5x. So combining a negative 1 and negative 5, we should get negative 6. So I'm going to write negative 6x. I'm going to keep it like this for now and then simplify a little bit later. And then we have a positive 7 and a positive 4. Those are going to make a positive 11. Alrighty, so we have all our terms grouped together. I'm just going to simplify this just a little bit more. So we have 13x cubed. We're going to add on this x squared. Again, we can't combine any of these because they have different powers. And then instead of writing plus a negative 6x, we can just write minus 6x. And then we're going to write plus 11 at the very end. So we had 4 different types of terms to begin with different powers. And so we should have 4 different types of terms at the end here because nothing canceled out, but we were able to combine some like terms with each other. Finally, for number 16, we have another similar one to 15, but we are subtracting this time. So let's be careful and flip everything in the second parentheses. So we have negative 7w cubed minus 4w squared plus 5w, take away 9. And we're taking away a negative 2w cubed, so that's going to be plus 2w cubed. Then we're taking away 9w squared, so we should take away 9w squared. Then we're taking away a negative w, so we're really adding a w. And then we're taking away a negative 3, which is really just adding 3. Okay, so this is what the entire thing would look like without parentheses. And then we can go on and combine some like terms here. So let's go with the w cubed. So we have negative 7w cubed plus 2w cubed. And that's going to be negative 5w cubed. And then moving on to the w squareds, we have negative 4w squared and negative 9w squared. So combining those, we should get negative 13w squared. And then moving on to the regular w terms, we have a positive 5w and then adding one more w. So if we do that, we should just add on 6w. And then finally, at the end, our constants, we have negative 9 and positive 3. Negative 9 and positive 3 are going to make negative 6. So I'm going to write that in parentheses before I go ahead and make this a little bit cleaner at the end. So cleaning this up just a little bit more, let's start with this negative 5w cubed. And instead of writing a plus a negative 13w squared, let's just write minus 13w squared. And then we're going to keep this plus 6w. That'll stay the same. And instead of writing plus a negative 6, let's just write minus 6. This would be our most simplified expression. So there you have 16 different practice problems with just adding and subtracting polynomials. When you're adding, just go ahead and combine like terms as you see fit. And when you're subtracting, just make sure you flip everything in the second parentheses before you combine like terms. So hopefully you found this video helpful. And as always, keep up the great work, and I'll see you in the next one.